stream just like you would for text files. Maybe. Remember that. All right, now we need, the way this works is when you write to a binary file, you're going to give it an address. It's going to go to that point in memory and it's going to start reading. And it's going to take whatever those bytes are, 1 byte at a time. Now what is a byte?
A unit of data.
A unit? That's not bad. Everything's ones and zeros though, right? So what's a byte? 8 bits. 8 ones and zeros is 1 byte. How many values can you represent with 8 bits? You can represent 2 with 1 bit, 1 and 0. If you've got 2 bits, you've got 0, 0, 0, 1, 1, 0, and 1, 1. That's 4 values.
What's the possibility?
There's a finite number. 256. 256 different values with 8 bits, or 1 byte. Anyways, it starts reading byte by byte through the memory as far as you tell it to go. So you're going to specify where to start. That's an address. And you tell it how far to go, and it's just going to write those bits to this file. Does that make sense? If you keep that in mind, it's kind of like pointers. This is a big nasty can of worms, but if you keep that in mind, you always know what's going on, sort of, in theory. So here we go. Let's say we have a structure. I don't know. I'm going to make it the weapon structure. We'll just put some primitives in there. And you can make that structure whatever you want. Now let's say I want to create an instance of this. I can do that. I can set my values. And now let's say I want to save this data in a binary file so that when I come back after the computer's been turned off, I can load this back up and I have all my data. So to do that, we're going to create an OF stream. We'll just call it out. You can do this in one line or two. I prefer to do it in one. You're going to give it a file name. If this file doesn't exist, it's going to create it. But I don't know, we'll just call it save. And then normally binary files are named .bin for binary or .dat for data. It doesn't matter, you can put whatever extension you want on there. And then we flag it with iOS binary so that it knows we want to write in binary instead of the typical text file. And then normally you'll put iOS out right there. Now this is an OF stream, so that's a little bit redundant, but it's still done, so why not? Then we're going to write. So we'll do it out.write. And this is where you're going to put the address of where you want to start writing, and then you're going to put the size of the data. Like how many bytes do you want to write? So if we want to write our weapon to this file, you need to cast it as the address of a byte. Now what is a byte in C++? What's an int? How many bytes? Int's 4 bytes. Float is 4 bytes. A double is how much? A long? How many is a long? Nobody knows. It's still 4. It's just like an int. You have to have a long to get 8. Short is 2, but a char is 1. So, char pointer is what we will cast this as. And sometimes you'll see this written as a reinterpret cast function. As far as I know, you don't need to do that. And I looked at it and I still don't know why people write it that way. But in Visual Studio, sometimes people do that. Ultimately, though, we just need the address of the first byte where we want to start writing. So I'm going to put that here, and then I need to give it the address of my weapon. How would I do that? The address of weapon, maybe. And then how big is it? How much data? We have a cute little function here called size of, and we can pass in our weapon. You can give it the one you made, or you can give it the actual class name. Either way, I believe it works. They should be the same size. And that will write this information to a binary file, and then we close the file. Always close your file. Does it open automatically?
Yeah.
This opens it. You could declare out, and then you can do it out.open if you wanted to do that. You can do it in 2 lines, but there's a constructor that supports doing it all in one, so why not? All right, so we run this. Let's just see if it runs. We shouldn't see anything happen, but now if we open our project, open folder in File Explorer, you should have your file there. And you should be able to try to open that. You can tell it to open it with Notepad. And you should get some weird squigglies in here. Notepad's going to try to read this as characters. It's going to do its best to read it, but ultimately that's just the 1s and 0s that were in the memory there. That's what got written to your file. So how do we read it back in? Let's try this. Yeah, we can make an IF stream in, open that same file, and this time we are coming in. But to test this, we need to change up our weapon, or we need to create a new one. So we'll just create a new one here. Weapon 2. And we can do n.read. And the arguments are pretty much the same. We're going to reinterpret whatever is here. We're going to cast it as a char pointer. We give it the address of where we want to store this data. So there has to be, this is important, there has to be some memory allocated for the stuff you're reading in. It doesn't go into the memory, start pushing things around to fit your contents from your file. We have to set up some space for it. So this does that. What if I did that? Would that work? No, because I've just got a pointer. I never created an object. I don't have room in the memory for these two variables. I just have a pointer that could point to a weapon. This way though, the weapon is created on the stack and there are two spots in memory for those variables. So here we go. We're going to read in the address of weapon 2. How big? Size of weapon. And then it would probably be good to come up here and make a display function that shows us what's going on inside here. So cout the damage, and then cout the attack speed. And then, just to see if our load works, we'll call display on the weapon 2 before we load. And then we'll load up and display again. I like to put this stuff here because it's easier to read that way. If you just start writing cout statements in small programs like this, you can get away with it and you'll know what you're doing. But if you get a large program and you've got just a bunch of random data being spit out all over the screen, you don't know what anything is. So you get in the habit of labeling your output statements. All right, let's run this and see if it works. So before I load, this is what I get, which is to be expected, right? I made a weapon 2. I didn't set any of those variables, so I get garbage. And then after loading, we get the variables, or we get the values that we set in our save file. And in the notepad, it looked weird, but you can see it knows how to read it. Read it back in properly. Was everyone successful? That's not good.
I just haven't finished programming all of it.
All right, what do you need to see? Fred? Great sort of Fred. All right. Now we're going to save just like we did. We're going to write it out. We're going to close it. We're going to call it display. Let's fix display. To include a name. We're saving it. We're going to create a second one. We're going to call display and make sure it's all garbage. We're going to load it up. And then we'll call display again. So let's just see if this works. So I got an error in the X utility file. Let's see how far the program got. It looks like it kind of worked, but it still crashed. So I'm going to stop the program, close the console, and then I'm going to comment out the whole saving part. Try again, just loading it up. Error reading characters of string. I wonder if that was on the first pass or the second pass. Looked like the first pass went okay. The second pass, it didn't load anything in. If we open our file up, this is what I got. That's what's new, right? We had the 33 and the @ symbol before, at least I did. Now I've got all this gibberish, but it's not characters. It's not, great sort of Fred or anything like that. And so that's why when we try to load this back up, it crashes and burns. And so working with binary files, you can see how it very quickly breaks down and becomes difficult. What if I don't know, let's make it a little more interesting. Let's make a class. Just give him some stuff. We'll give him a constructor. Default. Oh, it's not a class, is it?
That's
It's a race?
Ranger. Ranger's a class.
Ranger? Okay. Ranger. I can't spell paladin.
Of course you say paladin. Just saying, listen on classes, man.
Okay. Rangers. Yeah, Rangers are probably cooler than paladins. What kind of ranger is he?
Evil.
The Chaos Ranger? Okay, this is not entirely different than what we just had. Let's see if this works. This will be a class, that's what's different. We're also going to have more than one string. And it becomes important to put more than one word here for some of these. That's why I put Chaos Ranger there. I'll put something else there just to have some spaces in there. All right, instead of, I don't know if I want to go through all that. We don't have much time, because we lost a lot at the beginning. Let's hold off on that. Anyways, what we could do here is for our hero, we could have a weapon pointer. Or it might just have a weapon. If it had a weapon, would it be okay? No?
Yeah.
Actually, we can do this pretty quick. Let's just uncomment all of this, select everything, do a Control-Shift-H. We're going to replace weapon with hero. I don't see options to we can match case. Maybe that will help. Do a replace all. Yes. Okay. I don't know. That saved us a little bit. So our hero has damage. I don't know. I didn't want to do the entire thing. Messed it up. This should be a weapon. This should be a hero. I was thinking it was only going to do the selection, but it did the whole document. That didn't work out very well at all. I'll try again. Control-Shift-H. Replace weapon with lowercase hero.
In the look in, you can do selection. The third drop-down box. Select the second.
Selection. Yeah, that's what I should have done. Okay, replace all. Good. Alright, and now I just have to update these. These can be no, the constructor will take care of that. And we'll have to write a display method for our hero. That will take a minute. We'll hold off on the weapon for now. Wait, no, we can do that. We already have a display method for it. So for that cout, we can just say weapon I'll do a \n and then do weapon.display. All right, let's look over main. We're going to create a hero. We're going to save it to that file. We write the hero, we close it. We create a second hero, we call display. We load in from our saved file, and then we call display again. Let's see if it even runs. Okay, it crashed. We got default noob, we got ranger, we got chaos ranger. All of that worked. This worked. Weapon did not. I guess it never got set. Other than the fact it's crashing at the end, this is working relatively well.
That is a slow attack speed.
What? The attack speed is relative. Okay, so to get around the crash, there's a few things you can do. You can create a save function inside your class. So save here, and then we can do a load here. This is normally what you would want to do anyways. And then you're going to take from main these 3 lines, cut them out of main, and paste them into the save. And we'll have to change hero. Since we don't have the object, what are we going to put here? This. This is a pointer, so you don't need the address of. And then size of, you can do, class, or you can do this, dereference this. And then for load, we'll do something similar. Take these 2 lines. I never did close this file, n.close. And again, we're not doing the variable name, we're doing this, and we'll just leave it as size of hero. And now to modify main, I would do hero.save. And we have hero2, hero2.load. Now this is a little cleaner, a little more contained, but let's see if it runs. See if we can at least get the same results. The crash is there. Looks like most of this is fine. I'm curious as to whether or not our weapon is working, so let's make a weapon constructor. And once you've got your constructor there, run it again, see how that works. All right, all of that seems to work just fine. Other than it's crashing. Let's forgot what I wanted to do here. Let's cut the saving part and turn that into comments. Run our program again. Let's see if it can draw. Let's see if it can read purely from the file without any setup there. Okay, so our weapon name got a little bit skewed. Or is, yeah. The integers worked, the floats worked, the name, the strings can get messed up. So let's deal with that. So you can step out of binary, so to speak, and start writing this stuff as a text and still put it in your binary file. Just have it read and write that part as text. So let's try to do that. We've got a name, a class, and a path that we want to save, but we don't want to mess it up. So for this, instead of writing the entire thing, we're just going to write the parts that we want. We could try to write the weapon, but it also has a string in it, so it may have the same problem. We can write the hit points though. So in save, instead of doing that, we'll give it the address of our HP and the size of HP. We'll write that part in binary. And for the rest of this, we can write our name. If you don't put an inline here, it runs it all together. And then when you read it back in, it doesn't know when to stop. So we'll put our name, our class, and our path. And then when we load back in, we'll have to follow the same rules. All right, so we'll need to save again with our new saving stuff, and then we'll load it in again. Let's see if it runs. Anybody see a problem here? Yeah. So when you're reading back in like this, it's the same as when you're using CN. It only grabs one word, and then any spaces are going to cut that off. So if we have multiple words, we'll need to use Getline. But you use it the same way. So you Getline in, comma, name, and get the whole name. And this, when we use Getline, that's why it's important to have these on there. Otherwise, it will read in everything, just for name. All right, so once you've got that, change to Getline. Try it again, see how it works. All right, we have our name, our class, and the path. Our hit points came out and went in okay. So let's modify this a little bit. Then we'll save it. Then we comment out the save. Then we load it in and see if it actually works. So his name will be Fred Strong. Friends. It doesn't have to be, what are we, a ranger? Maybe he's a priest, or whatever you want. But change it up. Exorcist. Save that. I'm going to comment out the load. I'm just going to save my new data. That works. There's no crash. Comment out the save, uncomment the load, and see if that works. Seems to work just fine. Now what's interesting is if you open this up, the strings are still there, like text files. The binary data is also there somewhere because we got all that back. But that helps you deal with strings. And then what if our weapon was a pointer? So weapon's a pointer. We'll set some values. How do you deal with that? There's a couple of ways you can deal with it. You can give every object its own load and save functions. And then from hero save, we could call weapon save. And if that's written correctly, it should work. Then when we load, we'll call weapon load. It will load it in. But the point I'm trying to make here is whenever you do a write, it's only going to write at that address. And so if you just write your pointer, you've got the address to some place in memory that was a weapon, but once your computer is turned off, or even if the program restarts, that address is going to be used for something else. That information is no longer there, so that pointer, that address is no longer reliable. And so it's important that you go to the address when you save, and you store the data that's there, not just the pointer. Does that make sense? Everyone follow what I'm saying? Anybody follow what I'm saying? Nobody follows what I'm saying. If we do this as a pointer, let's try it out. Let's see what happens. We get our default values. Let's change it up. Before we save hero 1 here, we'll say hero's weapon damage is over 9,000. We'll save that. So I'm not going to load it. I'll comment this out. I'm just going to save it with that change made through a pointer. That worked. What's my save function doing up here? It doesn't save the weapon at all. So I don't think if I load that back up and call it, there's no way it's going to have that information. So how do we modify this? We need to, when we save our hero, we need to save the weapon data. The weapon is a pointer. How do we deal with that? Anyone have a guess?
Add the weapon to the save.
We definitely need to put it in there. It's not a string, so I can't do this.
Can we use that first line, the out right?
Let's try it. Now, weapon's already a pointer, so we don't need to give the ampersand there. You can do size of weapon or size of weapon dereference might be safer. And then when we load, we'll have to load it in the same way. No, weapon, size of weapon. Program ran. I'm going to comment out the save, uncomment the load, see what we load up. It crashed on the weapon string. That's expected because we haven't dealt with that. But we didn't get our... We didn't even make it to the damage though, did we? Let's take the name off of the weapon for now just to minimize confusion. Let's see if it can deal with just primitives. So here we go. I'm gonna save. We're gonna load. Hey, it worked. Woohoo! So there, saving an object with pointers. Now the better way to do it would be to write load and save functions for a weapon. Then we could also include the weapon's name in there, and you follow the same procedure that we did for the hero. But that's how it works. And you can see now kind of why people might shy away from binary files. It's a little bit complicated, but if your structure is really big, and especially if it's a lot of primitives, not strings, but just floats and ints and stuff like that, you can save them all really quick and load it up really quick. And it doesn't, those files are very small, they're very compressed. So there you go, there's binary files. We'll take a break and we'll come back and look at the asteroids game for just a minute, and I'll tell you what we're going to be doing with that in combination with binary files. Just set the timer back to 0 here, and I'm pretty sure that clears it up. Otherwise, it holds on to the timer from before. Yeah, that fixed it. And then the last thing I wanted to do was change the way the player slowed down. If you remember, I said this was a janky way to do it, and yes, Shane.
Oh, mine doesn't fire at all after doing the timer equals everything.
Doesn't fire at all? Oh, you ran your timer backwards, remember? So if you're that one guy who did everything backwards, you have to continue doing it backwards. Set your timer to whatever the bullet time should be. 2 or... If you're counting down, you have to put it at your starting point. And then for the slowdown, I think, I can't find my notes on this, but I'm going to attempt it right here. I think I put minus equals 1/2 of the velocity times delta. So that's, we're going from times equals 0.999 to minus equals 0.5 of the velocity times delta. That may be wrong. If this is wrong, I'll just have to go look it up, because I've got it upstairs. I just don't have it here. But that should slow it down. It should be a little smoother. Yeah, and now it's time dependent. So instead of being based on how fast the computer is, it's based on the amount of time that passes. That gives you a much better braking system. Little smoother behavior overall. So that's in the player update. Velocity minus equals 1/2 of the current velocity times delta. And then if you wanted it to be a little less drifty, you could change this number, do something more than 1/2 or less than 1/2. But that's how you have a much better braking system with that math. Okay, for the lab. Right now, we've got, what do we have? Okay, right now we have a scoreboard up here, and we can shoot, and you should have at least 4 asteroids. What I want you to do is make sure these asteroids are moving slower than mine are, and I know it's really bad trying to stream this through Land School, but they should be going slower than that. You do need your scoreboard up here. On the other side, I want you to put an FPS counter. All right, you've got everything you need to know to make such a thing. So you're going to have to make an FPS counter and put that over there. And then you're going to make it to where the player can push Control S, and that will save to a binary file. You want to put a timer on that Control S, because just like shooting and everything else we do, it's going to take that input a million times before you get your key up. You just want it to save once. You don't want it to save over and over and over again. So somewhere, maybe in your pull event loop, you should program it to where Control S saves out to a binary file. Here's what you're going to save. You're going to save the player, and you're going to save the asteroids, and you're going to save the score. The bullets are not important. I don't care if they, the player can be loaded back in with a full magazine, and that will be just fine. Don't worry about trying to save those. But save the player, his location, his angle, and save the asteroids. Now we're going to reduce the asteroids to 2, but if they are shot and split, then that needs to be accounted for. But you're only going to start with 2, and they need to move relatively slow, and the reason for that being is when you load the file back in, you don't want to get the player ran over. Well, we don't have collision detection for that anyway, so it'll be fine. I was thinking we had player collision, but we don't. But still, reduce the asteroids to 2 and be able to save and load. Any questions on that? I've got it written up, and I'll put it on Moodle here in just a second. But you're going to add an FPS counter, save asteroids, save the player, save the score. You'll have a week to turn that in. FPS counter is really easy. Don't overthink that. It's only a few lines. You can make a class for it if you want to. Yes. It should already show the score.